Bismillahirrahmanirrahim. My beloved students of class 12, more specifically the students of English version, those who have the subject statistics, listen. This is Muhammad Ashraful Azim, lecturer in statistics, English version day shift, Raju Uttara Model College, is going to deliver a lecture on statistics second paper. This is fifth chapter. The topic is Poisson distribution, and this is the part of the syllabus of your pre-test examination. Dear students, I expect that after completing today's class, you will be able to know what is Poisson distribution, what is the definition of Poisson variate, then what is the difference between binomial distribution and Poisson distribution. Later on, what is the parameter of Poisson distribution and the some important properties of Poisson distribution as well as the uses of Poisson distribution. This is the learning outcomes of today's class. Okay, let's see Poisson. From my experience, I observed that many students pronounce the word poison. No, it is not poison. Poison means toxin. There is single S, that is Poison. That is poison, and its synonym is toxin. But Poisson is a mathematician as well as physicist as well as statistician. He is the French mathematician and physicist, and he discovered the distribution, and by his name the distribution is known as Poisson distribution, and its full name is Simon Denis Poisson. He is the French mathematician and physicist. Okay, Poisson distribution. We are going to learn what is Poisson distribution. First of all, I would like to say that in the part of the syllabus of year final examination, there was a distribution which was discussed, that is binomial distribution. And if you learn the binomial distribution in detail, then Poisson distribution is very easy to understood. Now, binomial distribution, we understood that the characteristics of binomial distribution is a distribution of discrete random variable. We know there are two types of random variables, which are discrete random variable and continuous random variable, and Poisson distribution is a distribution of discrete random variable. And in Poisson distribution, mainly there is a relation between binomial distribution. It's nothing but a limiting form of binomial distribution. I repeat, in a word, in a sentence, what is Poisson distribution? Poisson distribution is a limiting form of binomial distribution. Now, what is the limit? In binomial distribution, we understood that if the number of trial is small, that is less than 30, that is the value of n is less than 30, and the probability of success is large, in that moment this is this binomial distribution. But if the number of trial n is large, that is n tends to infinity, and probability of success is very small, merely 0, near about 0, that is p tends to 0, and the product of n and p is m, which is constant, then the limiting form of binomial distribution is known as Poisson distribution. So there are 2 points: number of trial n is very large, that is greater than 30, and probability of success is very small, that is tends to 0, and the product of n and p is m, which is a constant. Then the limiting form of binomial distribution is known as Poisson distribution. Now, probability function of Poisson distribution. Actually, probability function, it's a function. It's a mathematical form. So, when the variable is discrete random variable and its function mathematical form is probability function. But if the mathematical form or function for in case of continuous random variable, then the function is known as probability density function. Here the function of Poisson distribution and the Poisson variate is a variable or distribution of discrete random variable. That is why its function is probability function. Now the probability function of Poisson distribution is p of x equal to e to the power minus m to the power x divided by x factorial, where x equal to 0, 1, 2 up to infinity. Here the identity of the symbols, x means Poisson variate, p of x means probability function of Poisson variate, e be the Napier log, its value is 2.71828, m equal to np, which is the product of the number of trial and probability of success, and it's a constant. Now, what is Poisson variate? A discrete random variable, when it follows this function, this probability function, then the variable is known as Poisson variable. The variable and variate are similar. So, this is the probability function of Poisson distribution. Here only one variable, this is x. This x is known as Poisson variate. Now, a very important topic is parameter. Parameter is unknown constant. It is an unknown constant. So, here p of x equal to e to the power minus m to the power x divided by x factorial. This is the probability function. So, what is x? X be the Poisson variable, e be the Napier log. So, in the whole function, we see only one unknown quantity, which is m. This is unknown constant. This unknown constant be the parameter. And the definition of parameter is the unknown constant by which any numerical value calculated from the population is called parameter. So, in this probability function of Poisson distribution, we see only one parameter, which is denoted by m. Normally it is denoted by m. Sometimes it is denoted by lambda or any other symbol. Now we are going to discuss the very most important properties and characteristics of Poisson distribution. Firstly, it was mentioned that the Poisson distribution is a distribution of a discrete random variable. Then in this distribution there is only one parameter, which is normally denoted by m, where m be the product of number of trials and probability of success. Later on, in Poisson distribution, the mean, variance and the parameter are same. That is, in this distribution, which is mean, that is variance, that equal to parameter. Symbolically, expectation of x equal to variance of x equal to m. Now, another property of Poisson distribution is sum of all probabilities of Poisson variate is 1. The coefficient of skewness of Poisson distribution is 1 divided by root over m, where m be the parameter. The coefficient of kurtosis of Poisson distribution is 3 plus 1 divided by m. We know the kurtosis is compared with 3. And the standard deviation of Poisson distribution is square root m. We know the positive square root of a variance is the standard deviation. Since The variance is equal to the parameter of the distribution. Parameter is m, so variance is m, and its positive square root m be the standard deviation of the distribution. These are the very most important criteria or properties or characteristics of the distribution. Now we are going to learn the uses of Poisson distribution. To determine the number of patients affected by coronavirus in the world is an example of Poisson distribution. To find out the number of defective items in quality control statistics. To determine the number of deaths of coronavirus. The single out of 40 products of a meal or a factory. To count the number of bacteria in biology. These all are the uses of Poisson distribution, and this is all about today's class. I expect that if you learn this topic very clearly, after that you'll be able to solve the different problems of the chapter, and these are the basic idea of the chapter. My dear students, thank you very much. Namo today. Allah Hafiz.